name is Illan Sigar, it's a metric number CF210330, and I will discuss on the executive summary and introduction. For our project for structure analysis, each group consists of 5 persons per group, and each group need to run an analysis on truss bridge. There is two parts of task that we need to work on, which are part 1, layout and design, where we need to choose a design and come out with a layout and dimension. Then for part 2, we need to do an analysis based on the design that we have choose. Our team have choose bridge design with 24 meter length and 4 meter height. Design of the truss is spread truss, and this truss bridge is intended undergo 300 kN dead load of point load. Value of its load and deformation will be calculated manually and also by using application of Lean Pro. As you can see in the diagram, it shows that there are a lot of unique designs for trusses ever built. Bridge is an important transportation infrastructure to connect two destinations effectively. The building of a strong and stable infrastructure must take priority over all other activities in order for the bridge to remain stable. Because of that, we need to be able to determine the reaction of individual components upon loads. The ability to determine the reaction upon loads will providing a clear safety measure for any type of transportation that use the bridge. Secondly, to understand the process of trusses design. A good trusses design will deliver a strong and usable bridge structure. Lastly, to ensure the stability within the trusses system. A trusses system should deliver a stable structure since it's working with a lot of joints.
Hi, my name is Fierderick Exzellvier Rudi, and my metric number is CF210276. Today I will explain about the layout and design part 1. First, we need to find the determinacy of truss bridge. For the bridge, we have member 21, reaction 3, and joint 12. After that, we will using the formula to check the stability, which mean is M plus R equal to 2J, and then we get 24 equal to 24, which mean the structure is stable and it is static determinate. Next is truss analysis part 2. We will use the manual calculation. First, we need to find the reaction force at each reaction. For Ly is 100 kN and Ay is 200 kN, and the moment reaction is 0. To find the internal force, whether it compress or tension, we will using the method joint. This is the calculation for joint A, and then we calculate all the joint. After done with the manual calculation, then we will compare the data with the Lean Pro software data, and this is our data comparison of internal force due to real load.
Hi, my name is Jefferson Chantong and Jemat, and my matrix number is CF210178, and I'm going to present the virtual forces. For virtual forces, which means there are replacement occur at one joint, which is located at joint E, and also applied with 1 kN. Repeat the step to find the internal and external force, but this time based on 1 kN that been applied just now. Next step is record the comparison data of internal force using manual calculation and Lean Pro software due to virtual load. Lastly, this is the table of deflection. Our area is 0.0004 meter square, and our modulus of elasticity is 200 times by 10 power of 6 kilonewton per square. So this is the formula for area of E, which is N times by N times by L divided by AE times by E, and the total is 0.174 meter. That's all for me. Thank you.
Hi, my name is Alto and Jarup, and my metric number is CF210274. Today I will present my group project which is layout and design part 1. As we can see here, on the left side is our existing truss beam as our reference, and on the right side is our free body diagram that we use AutoCAD to design it with 34 meter length and 4 meter height. For another design, we use Lean Pro software to design a bridge because this app can calculate internal forces and also deflection and that bridge that we design. On the project, we define support action at the end of a structure bridge. We put a pin support at the left side, while at the right side we put roller pin. Actually, we want to put a distribution load along a bridge with 30 kN, but we enable to put the uniform distribution load in the Lean Pro. For reaction, in the Lean Pro software, we got reaction at pin support is 200 kN, but in roller support we got 100 kN. So from that value, we can calculate internal forces for each member at the structure bridge. For axial forces or internal forces, we can see here at the blue line, which is upward is compression forces, and downward with red line is tension force. For deflection, we found that maximum deflection located at middle point joint 2 and 3, which is value 0.07043, and it is downward. And that's all from me. Thank you.
Hi, my name is Johnathen Leong. My metric number is CF21052. So for discussion, in this project we use the Lean Pro to analyze and design our bridge structure. After that, we propose our lecturer to a design that we met for approval from him. It is a model that is 24 meter long and 4 meter tall. In the construction of the model bridge, 3 different types of the force load response and internal member force are identified. These members are crucial to the ensuring the bridge can support and carry load safely. We calculate the internal force of the bridge using one approach, and we calculate the vertical deflection at joint E using the virtual work method. The joint approach is the simplest way to identify the unknown force affecting the particular truss member. The results show that there are not many differences between manual and computer computations. The calculation of internal force has a maximum error of 4% and a minimum error of 1%. The inaccuracy are likely the result of inadvertent human error as well as the accuracy of the software real design. So next is the conclusion. For conclusion, we have learned how to calculate the internal force and deflection in each of the trusses. We discovered that since bridge link people and transportation, they play a significant role in our daily life. Additionally, we were able to comprehend the load and composite strength of the trusses with greater clarity. Identifying a structural strength is crucial in the field of civil engineering. In this project, we determine the bridge truss strength using the joint approach in order to solve a system of linear equations whose size relies on the number of elements and knots in the trusses. It will be essential to find the tension and compression using the method described above. A civil engineer has a lot of responsibility while designing and building a truss bridge, since they must ensure that the design is appropriate and have a high level of safety. Before taking any action, the engineer must first analyze and comprehend the truss in order to prevent any occurrence or problem from happening. That's all from our group. Thank you.